Okay, final part of lecture 5, action perception couplings or sensory motor couplings. We talked a little bit already about the idea of know-how. I want to say a little bit more about it. And particularly in the context of craftsmanship. Here on the slide we see Joep Frens, my former colleague at Eindhoven University, who is a real craftsman. Um, he has, if you could say, knowledge in his hands that is very difficult to explain. I mean, he could tell me how to cut something really straight in cardboard, but I couldn't do it. I'm terrible at it. So there's something having to do with the skill and talent that you have and many years of practice that you have that makes you build up a certain know-how relative to a task. And um, this this kind of knowledge is what we call embodied knowledge. So it is knowledge that is not easily transferable in the form of a symbolic representation like a text or a picture from one person to the other person. It is really completely um, incorporated. You need your whole skilled body in order to effectuate that knowledge in the outside world, and there's no other way to get this knowledge out other than through your own hands in actually doing the thing that you're good at, right? The philosopher Gilbert Ryle made this important distinction between know how and know that. And he was not doing that just um, as a description of different kinds of knowledge. He was actually quite critical about philosophers, all the way going back to Aristotle, who said that the knowing that, so declarative knowledge, knowledge of facts that you could write down and formalize and make precise in text or language or mathematics, that this would be the real and only form of actual knowledge, and everything else would be sort of praxis or skill and and therefore in some way not to be taken seriously. Ryle said, well, this was actually a big mistake, mainly also in contemporary psychology, to think that knowledge is something that is abstracted away from behavior. Gilbert Ryle was a behaviorist who said, no, knowledge is the behavior, right? To be able to do something right, that is the knowledge. There's not a separate internal knowledge that you then execute in the form of an action outside, right? Note again and again, and I'm repeating, of course, this throughout the course, that in computers, this is actually the case, that there is this strict distinction. There's software inside the computer which defines what the computer can do in all kinds of different circumstances. And then there's the actual behavior of the computer, which always means that the software is telling the machinery to actually do something like print a text on a screen, move the robot arm, or what have you, put on the LED light. Ryle says in human beings and animals and so forth, there's not this distinction. This distinction is an artificial distinction that that human beings came up with when they started to reflect on themselves and they started to think for some reason that thinking and action were two separate entities. Now, why did the old Greeks and then after that in medieval times and then later on Descartes and all the modern uh, big big time philosophers all the way up to Heidegger, why did they all think that thinking was somehow separated from the physical body and action? Well, this has to do with the fact that there is, in some sense, this experience that we have that we can take distance from what we do, right? There is a in our everyday normal lived experience, there is there are these moments where you are engaged in something, you are completely in the flow, and then at some point you stop. you step back and you think, hey, what is going on here? And this moment seems to be different from behavior. Well, Ryle tried to push the point as far as he could to say, no, that's also behavior, right? When we step back and reflect, that's just another form of behavior. It's no longer hammering the hammer, but it's still doing something. It's still being with your body in the world, right? Even if you don't physically move all that much. Right now, I'm sitting pretty still, but still I'm behaving. It's not that when I'm talking and thinking, I'm no longer behaving, right? It's the same thing, but it just looks different. But still, of course, the reason why we think it's something different is because it seems to have some kind of meta level quality, right? So just hammering the hammer and driving in the nail is the behavior, or cutting the cardboard, as we can see in this picture. But then stepping back and thinking, hey, something's going wrong here, or am I doing this right, or what should I actually do? That seems to be a sort of meta level activity involved in it's a behavior that is about the other behavior, right? It has some kind of content that is about something else. So in some sense, you could say it's representational, right? It's making a plan, for example, or thinking ahead, or looking back, like was that right what I just did, or could I have done it differently, and what would that have mattered, and so on. And that's what we call thinking, right? Now, Donald Schoen very usefully said, well, this is what we call reflection on action, and it's not separate from action. It happens all the time, and it makes us it allows us to just not be completely only sort of mindlessly in the moment and just going with the flow all the time. We have this capacity, human beings and animals, no doubt to some extent as well, but very different from humans. We have this capacity to sort of at some point step back and say, hey, wait a minute, what's going on here, and then take a different direction. But as soon as we go in again, right, we're back in the flow. And I don't have Lucy Suchman on this slide, but Lucy Suchman famously had the comparison with being in a canoe on a wild river. And I don't know if I already said this in another lecture. I should re-listen to all my videotape lectures because by now I'm no doubt starting to repeat myself. Um, but Lucy Suchman wrote about the river and said, well, when you're in a canoe and you're at the top of the river, so to speak, and you're planning your descent, and you think, oh, I'm gonna sort of pedal pedal very hard to the right to try to reach that big rock, and then go around that rock and then go down the river and so on. That's when you sort of reflect on the situation. In this case, looking ahead. But then, of course, when you're in the river, you just have to improvise, and you have to stay alive and stay upright and don't fall down and so on. So you just do with whatever hits you at the moment, and you let your skills do most of the work. But still, this original plan of trying to get to that big rock, that's still somewhere in the back of your mind. So what this reflection and planning does is that it orients you in where you want to look. So even if you're in the middle of a big stream of a river and improvising and water all around you, you still have in the back of your mind, you have this idea, where's the big rock? So whenever you get the moment of chance, you look around, where's the big, oh, it's all the way over there. I need to go much. So you start to paddling even harder trying to get to that rock. Of course, you never reach the rock and you take a completely different route, but still your plan had some effect on what you're doing in the moment improvising, right? And Donald Schoen emphasizes that most of the time we don't do this ahead, right? At some point we start to plan ahead, but most of the time we look back. So planning ahead is mostly looking back and then taking a different step into the river again, a different direction when we step into the river. We don't plan ahead that much, but we look back and say, "Oh, that didn't go so well. That didn't. So what am I going to do? Oh, next time I'm going to try it a little bit different." And then you step in again and you improvise again. And he called that reflection on action. And as designers know, um, this leads ultimately to a reframing of the situation, right? So when you can reflect on what you do, and when this at some point leads you to see the whole problem in a new light, sorry, in a new way, then this will give you opportunity to improvise and respond and let your sensory motor couplings go again, but they will be different kinds of sensory motor couplings because you've you sort of you approach the whole situation in a completely different way. And that is the function of thinking, of reflecting on what you're doing. But it's not separate from action. It's very much tied into it. There's short moments where you step back from it and then you go back into that river and you're completely back into the flow of coupling of action and perception again. Right? We talked about Heidegger's Zusammenhalt. Finally, on this slide, there is Pi, who is a researcher of designers and artists, and what he and craftsmanship in general. And one important notion that I want to emphasize briefly here of his work is he calls this craftsmanship of risk. So what he says is if you draw a line on the paper, if you were an artist and you draw a line on paper and you draw it freehand, then you actually take a risk. So you take responsibility for that line. And whether the line succeeds or not to your own standards depends very much on your skill of drawing that line. But when you take a ruler to begin with, so like the picture here is already working with a ruler, and you draw a line over a ruler, then you sort of hand over part of the responsibility for the task to this external tool. But this makes your craftsmanship one of certainty, right? You you know that you're going to achieve the desired result as long as you use the tool in the right sort of way. And the tool is doing part of the work for you. Now, an embodied skill is one in which a lot of um, the quality of the outcome depends on your skill. So it's always risky. You can make a mistake, and when you make a mistake, the task fails, right? And that's basically what artists and designers and craftsmen are good at. Whereas if you the complete other side of this is a workmanship of certainty would be to completely automatize and mechanize the whole process and make it into a machine. And for this machine, you completely calculate on beforehand and you make sure that the machine produces exactly the result that you want to have in the end. And you ensure yourself completely that the machine will do what it's supposed to be doing. And then you only have to hit the button. And then when it goes wrong, you no longer have to blame the person that hit the button. Because what can that person do about it? That person will say, oh, there's something wrong with the machine, right? So the machine wasn't designed right. And that's a very different kind of way of getting work done. And in our society, you could say we have been focusing a lot on mechanization, automatization, industrialization of processes, focused on getting certainty, making sure that the desired result is met. But this sort of takes away a little bit of the quality that you get from drawing a freehand line, right? Which will never be completely perfect, but it will have some kind of intrinsic quality that has to do with what a skilled person that is expressing themselves in the environment is creating, right? Even if it goes wrong a lot of the time. I mean, that's the whole point of it, that it should go wrong a lot of times so that people can reflect on it and learn from it and grow from it. One more slide on the difference between knowing how and knowing that. And what you can think about yourself if you're designing interactions is whether you're designing an interaction that relies more on declarative factual knowledge, knowing that, or whether it helps a person develop a know-how, right? Now, if you think about how to navigate a city and get to a location, right, from your home to a certain desired location, if you depend totally on knowing that, you would just write down a description of what you should do. So this is a traditional directions that you give to somebody, and you have to know a lot of things. You have to know the Amsterdam Ring Road, and you have to know what Zuid-Amstelveen exit S108 is, and so on. You have to understand all these words, and then you have to translate that as you drive in the car. You have it in your head, the declarative knowledge, and you have to translate that into what do I actually have to do at this crossroad? So you're at a certain crossroad. Do I have to take this exit or not? Is this the one or not? Right? You have to translate it yourself in your own body. The next step would be to say, okay, um, what if I just give you a map? Then you can see on the map. You don't a lot of the words you don't no longer have to understand this abstract knowledge, but I can just see where it goes. I can say, oh, I turn left here and I go right there, right? So if you remember this video that I showed of people designing something together with the magnets, and they used a lot of these what they call indexical terms. So here, there, that, and this. This means that part of the knowledge that you need to solve the task, you no longer have to have it active in your mind. You just see it right there, right? So you don't have to name everything. You don't have to understand all these words anymore. You can just point to the map and say here, there. So that's easier, right? The next step, of course, is to represent this map in a different way. So to represent it in a 3D view that corresponds directly to what you're actually seeing when you look out the window. And of course, the ideal would be that it's completely augmented in your windshield of your car, right? So you see through the real world, you see the directions, and it's just as if somebody's pointing right in front of your eyes. Turn left here, right? That makes it even more in the world. And then in the end, um, you just um, um, yeah, I don't know what is the next step. So this would be an interesting question. Like, what would be the next step if you no longer see it anymore? Maybe it's in your glasses or in your ears, or you'll hear it, or you'll feel it on your body, right? Now, the interesting thing is, of course, that to some extent we are also de-skilling here. So when I'm using the TomTom navigation, right? Um, in a way, it's preventing me to do it myself. So you get these strange situations where some car driver drove into the canal because the thing said turn left here, and they just did it right away, and they weren't looking anymore. So what they were doing, right? So it's not as simple as making it more intuitive and more connected to what you're doing. If I'm using a tool in a skilled way, like a hammer, I'm the hammer is right there in my hands, and it's right there where I do the task, right? So the tool is fully integrated with my activity, but it's not the case that it's taking over. It's not that it's making me stupid, right? I'm still very much part of the activity, and I still very much have control over it. So there's even if it goes on autopilot, I would never suddenly drive in the canal, right? If so so if I read the text that is all the way here at the left, and I have incorporated it. I've sort of run through the whole thing and say, oh yeah, I know this. I know this building. I know this. And then you go. Then at that moment, the what you do is actually more skilled than if you would just follow the tom-tom, right? So it's not an easy mapping between these different interfaces on knowing that and knowing how that this slide may maybe suggest. It's more a matter of for each of these different representation forms, it relates to knowing how and knowing that in different kinds of ways, and you need to figure out the small details of it. Okay, so now we get to the point of How do we design for this, right? We have discussed all the theory. And my main question would be, and this is something that I've been writing about a little bit, that there is a lot of interaction design that is focused on creating the right sorts of information representations, but there's actually quite little of deeply worked out design on creating interactive tools that become a part of your sensory motor coupling, that really become a part of you, part of your system, so that you could really say, this is sort of a part of my extended body, if you wish. I've become a little bit of a cyborg, and I now have this extended thing, extended of my arm, extended of my eyes, extended of my skills, extending my skills. And there's not that much about it, and the reason could be, one of the reasons could be that it's just very difficult because it's not something that you can easily write down and visualize, right? It's very intuitive, it's experiential, subtle, subconscious, often, and not easy to pin down, right? Whereas a good representation, once you have it, you can just point to it and say, here, this is what it is, and you can easily explain what it is, why it works, and so on. So I'm very interested in attempts of creating interactive technologies that would actively, as we say, mediate sensory motor couplings or action perception couplings. So they become a part of your coupling of action and perception, and they start to influence this coupling in a certain way that gives you a new quality of and or a new kind of behavior or possibilities. You could boost the coupling, you could temper a coupling. For example, when you talk about um, addictions, right? If you're always eating too much, what would be a kind of, how could you, instead of telling a person, you eat too much, you eat too much, oh, this is not healthy, all information, all representational, all in the mind, how could you break into the actual couplings that lead you to constantly grab more food, right? Um, you could trigger new couplings, break couplings, transform, morph, and so on. One example that is from biology, so nobody really designed this. That is really is means a change in the body in such a way that the action perception couplings of people change. Is in a certain group of people, the Moken Sea Gypsy children. They are living in the South Pacific Sea, and this is a group of fishermen tribe, so to speak, and what they do is that they dive in the water to search for pearls, and they are very good at this, and fish as well. And the children, well, the adults as well, but already from the children, so it's inborn now. This group has evolved the capacity to actively change the size of the pupil relative to the task that they do. We Western people cannot, right? So I'm saying we, me. When the light changes, my pupil automatically dilates, it's not under my control. For these kids, it's under their control, so they can make a very small pupil on the water, and then they can actually see quite sharp without having to have glasses. So this is a change in the perceptual system, in the sensory system, but it completely relates. It belongs to it. It forms a part of the whole skill for them of how they fish underwater. Completely different example that is from interaction design itself. I like this example because um, there was at some point this nice um, new tool called siftables, and siftables were little blocks, and they were quite well received in the tangible interaction community. Um, each siftable has a small screen, and when you put the screens together, they start interacting. So what you see on the little screen is related to whether whether the physical block is located right next to some other screen, right? So by physically putting them together, the digital information on the screens changes and forms a meaningful relation, right? Like maybe a story or a mathematical equation or something like that. Or there was this, you see here, little moving pictures, and then when you put them together, they would look at each other and smile or something like that, like Harry Potter paintings. Well, all very nice and fun. And they made several applications with this. But what I really liked is that in the original movie that David Merrill, who is the designer of these systems, made, he gave them to his own kid. And what this kid was doing, it started to stack the siftables. And then you hear David Merrill say, well, apparently not all the users quite understood what was the idea of this tool, right? And not to say anything against David Merrill because he's a great designer, but I think he's actually wrong there. So I'm using here as an example. Um, it's the other way around. I think the kid understood something about this tool that the designer himself did not understand. Namely, if you make these kinds of blocks, the affordance of these blocks is that you stack them, right? So this stacking is actually what you should do with these blocks, just given the physical form of these blocks. That's the natural thing to do, and it has to do with our own bodies, our own skills, the social practical skills that we have as human beings of dealing with physical objects of about that size, and with the physical properties of those blocks. If you put that together, you create an action perception loop, and the result of that loop is that these things will be stacked. That's just what happens with these things. But that stacking the things had no meaning digitally. So the tangible interaction designer did not use this natural affordance of these blocks into the design of the interactive system and what the system means and what it can do for you, right? So here we see an example of where the the representational idea, so the things were still little screens, much more than they were blocks, right? And you can see also, I mean, there's digital information on a little screen and it's also a block, but it's still separated in a way, right? It's connected and it gives you new kinds of possibilities, but it's still separated. And because we are so used to focusing on screens, David Merrill did not design anything with stacking, but the kid, who is just a kid, just does what it comes natural to him, and actually shows us that we have not been paying attention to the tangible, still not have been paying attention to the tangible qualities of this system. Another great field of research that different people have been working on, mainly this guy here, Bach Irita, he called it sensory substitution. This is the idea of creating a new action perception loop that sort of makes use of your existing sensory systems. So what he did was he literally coupled the visual information coming in here through a camera and then projecting that on a grid with very light electrical stimulation. So you feel it on your skin. And then, for example, he put that on his back. And then he walked around with that for a long time. And then at some point, he started to sort of feel on his back the information that came in here through the camera. And his whole body and brain started to adapt to this information coming in. He also had a grid on his tongue, and he explored all kinds of different ways. Later on, there was actually a commercial product. This one, glasses. There's here in the middle, there's a camera, and the image from the camera is automatically translated to sound, and it makes sweeps. So it goes like, and this woman is a blind person, so a visually impaired person, so she cannot see, and she has been wearing this for quite a while. And what she's reported was that at some point she could see the door and walk right through it. So the gap of the door, she could see it, but it wasn't visual in a normal way. But it wasn't a specific sound. So it was not as if she started to recognize the specific bloop that would correspond to the door, because that was not how it worked. She had to constantly move. She had to sort of scan and move with her whole head so that this sweep would change and remind the way the visual flow changes in Gibson's theory, right, of the affordance and of the airplane fighter. She was creating a new kind of visual flow, but then auditory flow. But auditory flow related one-on-one to visual information, to spatial, well, let's call it spatial information, where things are relative to my physical body. That information was sort of present in these sounds, but it was not as if there was one sound that corresponded to one particular thing, right? She had to learn over time. Her brain had to sort of adapt and extract the invariance from it, just as we learn to do with our eyes. And at some point, it just becomes natural to you. It's deeply embodied. It's not a conscious thing like, oh, when it sounds like bloop, that's a door, and when bloop, that's not a door. It doesn't work like that. It just you it's a constant presence of sound, and at some point there is just the gap of the door in front of you, and you see it and we don't realize that the same is happening with our own eyes, right? We still think that there's this like, oh, when there's a certain pattern of data coming in our eyes, that is a tree. It's not, it doesn't work like that. Our visual system works in the same sort of way, that you develop these patterns of relating to your outside environment by constantly moving in it and by constantly having input in it. The same kind of example is from Jelle Steenstra, a designer from Eindhoven University. And Jelle designed a speed skate, and he put in the speed skate here sensor that was also related to the ears. So in a way, the same kind of idea. And this gave sort of low sounds. I think it was something like, and it was directly related to your actions that your feet made. He made it so that if you would stand on the front of the skate more, the sound would become higher in pitch. If you stand more on the back, it would become lower. And if you push hard, it becomes harder. The sound becomes louder. And if you push soft, the sound becomes softer. And you see here the pattern of sound. And again, the sound doesn't have a direct meaning for you when you hear it. You just hear some, yeah, ongoing sound, like the sound of the washing machine or your laptop, or like some kind of background sound, right? And of course, you hear a wave in it, a pattern in it, and you hear that it's related to what you do, but it's not immediately meaningful. But over time, your brain will start to sort of pick up on it and capitalize on it, because the brain works like this, that if there's something in the action perception coupling that works relative to what you are doing, right? If it's information that is meaningful to what you're doing, then the brain will start to pick up on it and make use of it, right? It will not leave information just lying there if it's correlated with what you do. If it constantly turns out that whenever you're trying to do something, this other sensory information is always there, right? Your brain just picks up on it and say, oh, I can use that information, and it will start to integrate it into into creating a stable coupling with the environment. In this case, not falling down and having a good stroke while skating. It's very different from when a trainer would say to you, "Oh, you're standing too much on the front." There's nobody giving any judgment, right? So in the information, there is no direct judgment on whether you're doing it right or wrong. There's an implicit normativity in it, in the sense that, of course, Jelle has decided to encode for standing more on the front or more on the back of the skate, and he knew from talking with skaters that that is important. It's important to keep your balance front and back in a certain way, right? If standing more to the right or pressing more to the right or the left, or keeping your arm in a certain way was really important, then he could have also made that into a sound as well, right? So he made choices. So you do intervene in a certain way, and that has a sort of intrinsic meaning, but there's not a symbolized thing in there saying like, oh, when you access a certain boundary, then the signal will go on and tell your headphone you're standing too much on the front, right? It's not like that. It's not this explicit prefab meaning that is communicated to you in a message. It's more a subtle open signal for you to pick up and start to work with and learn from. And the opposite is happening in all these standard tracking devices and sports devices, right? Here, the whole idea is that the device measures something of your body, and then it gives back a conclusion. So it doesn't give back the signal, but it gives back an already pre-existed, pre-processed conclusion of what you are you doing right or wrong, right? Is this green or red? So is it going okay or not okay? Did you get your target, right? All of that is explicit knowledge. It's knowing that, right? It's not helping you to develop a know-how. Well, maybe it can help you to develop a know-how, but it's very much more difficult, right? It's like getting the explicit information and then really having to translate that yourself all the way back down into changing your bodily skill. Well, that's difficult, right? It's like telling somebody, "Oh, here's some pictures of how to ride on a one on one wheel, right? This is how you should do. This is the theory. Here's a little booklet, riding on one wheel. This is how you should do it. Come to the circus," and then say, "Good luck. Just try it out." It can work, but can we do it? Can we do better here? Can we help people really develop this skill as they go along? That's my question. Now, finally, I want to say something about machine learning, because once you have this cycle of measuring from the body and then giving a feedback loop back to the body, like this speed skate, for example, a very obvious and quick thought that designers will have is, oh, can we put some artificial intelligence in there, right? Something that processes the data and then uh, but but really watch out with that, because what happens there once again is that you are letting the machine doing all the processing and the intelligence. So you're not necessarily, I mean, I think you can do it right or wrong, but you're not necessarily, when you put a lot of artificial intelligence in a wearable sports band or whatever, actually the wearable creates a know-how in some way. It's not really know-how, but because it's not doing anything itself, right? It's just a wearable. But the wearable is sort of extracting meaning from your data, but you are not. You just get the meaning on a plate, right? Whereas if you want to develop a skill and a know-how and an action perception coupling, if you want to change the way you see affordances for action in the environment yourself, then this machine learning should take place here in your brain, right? And of course, we can start to think about maybe having a kind of collaboration between a machine and a machine brain and a human brain. But we have to really be careful with that and think really deeply about what that would mean, right? If you don't think very carefully about it, what you will end up with is that you start to try to create a machine that becomes intelligent about you, and you don't necessarily become more intelligent about yourself. Now, finally, I want to show you an example of a nice movie of an interactive element in an semi-autonomous car, and I will show you the video. And for me, this example is actually a combination of both sensory motor couplings and social interaction. So it means that you interact with the car as if you have a talk with another person. But at the same time, you interact with the car not by talking and not by reading of words and pictures from a screen, right? So the modern day autonomous cars like the Tesla, they have big screens in them, and they become much more like desks with a laptop on it that is also a car in a way, right? But this is still a car where you feel what the car is doing, and the car feels what you are doing, and by feeling each other, almost literally feeling each other physically, you're able to communicate with each other. And I will just let the movie speak for itself. This is also a project from Eindhoven University, industrial design.
Oké, stop maar.
I'm going to work hard on recording the next lecture, because that's going to be about the concept of participatory sense making. And participatory sense making is, in a way, action perception couplings. So it's the whole idea of action perception couplings, but then specifically looking at how people interact with one another. So when I interact with you and you interact with me, this theory of participatory sense making says that we are making sense together in a participatory way. I participate in your sense making, and you participate in my sense making, and we both participate in a shared sense making process, if you wish. So the idea of making sense together socially, we already discussed when we had the lecture on socially situated practices. And the idea that this is kind of an embodied interaction loop, just like the example of the car and the driver that I just showed. This is sort of the basic idea of action perception couplings, and both of them are coming together in what is called participatory sense making.